Hello students, I have planned to give a series of lectures which may be useful for your NET examination. First, I would like to address a few issues regarding the strategy. First of all, you must read the questions very carefully, and next, you should not spend much of time on a single problem. If you get stuck with a problem, you just proceed to the next problem. And also remember that a number of problems could be done easily by choosing the elimination process with the help of various tools. For instance, dimensional analysis is an important tool which may be helpful to pick up the correct option in a few seconds. So these are the things you must remember. Having said that, let me try to solve a few problems in this lecture. First, I pick up a problem which says that if A, B and C are non-zero Hermitian operators, which of the following relations must be false? You see the relations that they have given, this and this. In each case, C is expressed, the operator C is expressed in terms of A and B. And remember and focus on this sentence that A is Hermitian, means A equals to A dagger, B equals to B dagger, and also C must be equals to C dagger, because all are Hermitian operators. Now let us check the relations they have given, whether they satisfy this relation or not. Now you see, if you pick up the option A, then C is written as AB minus BA. These are the operators, right? Then C dagger equals to AB minus BA dagger equals to AB dagger minus BA dagger, and which is B dagger, A dagger minus A dagger, B dagger. Since A equals to A dagger and B equals to B dagger, this should be equals to BA minus AB, which is nothing but minus A commutator B and equals to minus C. So eventually find that C dagger equals to minus C. That means C dagger not equals to C, and therefore in this relation it indicates that C is not Hermitian, and therefore this is the false statement here. Then we move on to the next problem, that given the integral 0 to infinity dx by y square plus x square equals to pi by twice y, then the value of this, you have to pick up the right one from these four choices. Now if you look at this integration very closely, you see x is the variable, the integration is done over the variable x, but y is nothing but a parameter. Now we have to have the integration over x, but we have to bring the denominator the square of y square plus x square, and therefore immediately and obviously we should attempt a derivative of this with respect to y on both sides. If you take the derivative, say d dy of integration 0 to infinity dx by y square plus x square equals to d dy of pi by twice y. Now in this side, this integration is over x but derivative with respect to y, and since they are independent, and therefore I can perform the derivative first and then we can carry out the integration, and therefore we can write 0 to infinity d dy of 1 by y square plus x square, and then dx equals to minus pi by twice y square. Now here it is 0 to infinity, and it should be in the denominator y square plus x square whole square, and then minus twice y dx equals to minus pi by twice y square. Now this minus sign cancels, and since this is a parameter independent of x, we can bring it down here, and therefore 0 to infinity dx by y square plus x square whole square equals to pi by 4y cube. So this should be the answer, and let's see whether this kind of choice is there. Yes. So therefore this is your answer. Now next problem, let's move to the next problem. Problem say 3. It says that loaded dice has the probabilities of 1 by 21, 2 by 21, 3 by 21, 4 by 21, 5 by 21 and 6 by 21 of turning up 1, 2, 3, 4, 5, 6 respectively. If the dice is thrown twice, what is the probability that the sum of the numbers that turn up is even? Okay. So basically it is a biased kind of dice which has probabilities different for different numbers to appear. Now suppose you throw the dice once, okay, then what is the probability that you will have a odd number or a even number? Now the probability that you have a odd number would be either it appears the phase 1 or phase 2 or phase 1 or phase 3 or phase 5, and therefore the total probability that of occurring the odd number is 1 by 21 plus 3 by 21 plus 5 by 21 equals to 9 by 21. Then what is the probability that even number appears? That should be 1 minus 9 by 21 equals to 12 by 21. So this is the probability that any of the odd numbers will appear in a toss, and this is the probability that any of the even numbers will appear in the toss. Now in the second toss, because the second toss is independent of the first toss, and therefore in the second toss also you have the same probability 9 by 21 for the odd number to appear, and this is the probability for the even number to appear. And we want in both the trials, this number 1, trial number 1 and trial number 2, we want the number appearing here and the number appearing here, the sum of these should be even. Therefore the only possibility that both this should be odd and this also should be odd, and or this should be even, the first trial number should be even, and in the second trial number also should be even, and therefore the total probability of the sum equals to even. Total probability of the two numbers appearing in two trials, the sum of those number is even, equals to odd and odd, that means p odd into p odd, or means plus p even into p even. Okay, then that should be equals to p odd is 9 by 21 into 9 by 21 plus 12 by 21 into 12 by 21, and therefore 81 by 441 plus 144 by 441 equals to 225 by 441, and therefore the correct option is this. Okay, and the next problem we will be working out is this. Which of the following cannot be the real part of a complex analytic function of the complex variable z? So you are given 1, 2, 3, 4 choices, right? Now if a function f of z is a complex function, that you can write as u x y real part plus I v x and y, right? And then this function is analytic if it satisfies these real and imaginary parts satisfy Cauchy-Riemann condition. that is del u by del x equals to del v by del y, and del u by del y equals to minus del v by del x. Now if you take the derivative once more with respect to x, then del 2u by u by dx2 equals to del 2v by del x del y, and del 2u by del y2 equals to minus del 2v by del y del x. Now if you add this, if you add them, then del 2u by del x2 plus del 2v del 2u by del y2 equals to del 2v by del x del y minus del 2v by del y del x equals to 0. That means that u has to be harmonic. Now you have to test the given u. If this condition is satisfied, then that can be a real part of an analytic function, and if it does not satisfy, then that should not be cannot be a real part of a complex analytic function, right? So let's check with this number a. Now if you take del 2 by del x2 of x cube y plus del 2 by del y2 of x cube y equals to, this one should be 6xy plus this should be 0 equals to 6xy. So for non-zero x and y, this is not equals to 0, and therefore this cannot be a real part of a complex analytic function of a complex variable z. Okay, so you need to check this condition. Okay, and similarly one can ask for the imaginary part also. For that also you have to do a similar type of test. Okay, now the last problem today that I am going to work out is a particle moves in a potential which is given like this: x square plus y square plus z square by 2. Which component of the angular momentum is or are constant of motion? Now see, if you think of the spherical polar coordinate system, if this is your r, if this is theta, this is z, this is x, and this is y, and if you take the projection here, this is equals your r sine theta, and the z component is r cosine theta, and therefore you can write x equals to r sine theta, and if this is the azimuthal angle phi, sine cosine phi, and y equals to r sine theta sine phi, and z equals to r cosine of theta. Okay, then your potential that is given, say r and theta and phi, it can be written as x square means r square sine square theta cos square phi plus r square sine square theta sine square phi plus r square by 2 cosine square theta equals to r square sine square theta common cos square phi plus sine square phi plus r square by 2 cosine square theta equals to r square sine square theta plus r square by 2 cosine square theta. You see, and therefore the potential that you have, it is independent of phi, and therefore the Lagrangian is also independent of phi. Then it is kind of a cyclic coordinate, this phi, and corresponding conjugate momentum p phi, that should be a constant motion, constant of motion, and therefore and p phi is related to Lz, and therefore the z component of the angular momentum should be a constant of motion, and therefore the answer should be this. So let me stop here today, and again I'll come back with few more problems and so on. Thank you so much.